Welcome to Study Loop.
The problem is if a function of one variable is continuous on an interval and has only one critical number, then a local maximum has to be an absolute maximum. But this is not true for functions of two variables. Show that the function f(x,y) is equal to 3x times e to y minus x cubed minus e to 3y has exactly one critical point, and that f has a local maximum there. That is not an absolute maximum. Then use a computer to produce a graph with a carefully chosen domain and viewpoint to see how this is possible. So first, we compute partial f, partial x. This is equal to 3 times e to y minus 3x squared. Partial f, partial y is equal to 3x e to y minus 3 times e to 3y. So if we let each of them be equal to 0, we have x squared is equal to e to y from equation 1, and we're applying this to equation 2. We have 3 times x cubed minus x to the power of 6 is equal to 0. So we have x is equal to 1. Since here x is not equal to 0, since x squared is equal to e to y is always greater than 0. So we have x is equal to 1. In this case, y is equal to 0. So 1, 0 is the only one critical point. Then the second partial derivatives, f(x)(x) is equal to negative 6x. f(xy) is equal to 3 e to the power of y. f(yy) is equal to 3x e to y minus 9 times e to 3y. At the point 1, 0, f(x)(x) is equal to negative 6, and f(xy) is equal to 3, fyy is equal to negative 6. So d is equal to 27 is greater than 0. Since f(x)(x) is less than 0, at this point, the function has a local maximum value. But this is not an absolute maximum value, because if we let y equal to 0, we can see f(x0) is equal to 3x minus x cubed minus 1. So when x goes to negative infinity, we can see f(x0) goes to positive infinity. So the function f has no absolute maximum value, since when x goes to negative infinity, f(x0) goes to infinity. Now let's look at the graph of the function f. So we can see this local maximum value is not the absolute maximum value.